right? When we do questions, we get difficult questions, easy questions, theory questions, likewise. So today we are discussing small theory questions. These small theory questions are really helpful when you are doing difficult questions, because you can easily identify small theory tips from difficult questions from the points that are given. So here we are discussing around 30 questions from mechanics. You just look at the question and the answer should pop up into your head. It's that easy. If you don't know these answers, that means you don't know theory. So you have to work on with your theories. Remember that these questions are really easy and you should know the answers. At least 25 out of 30 has to be correct. Right, let's go. Let's see the question. And right, let's start with the first question. The most suitable unit for expressing nuclear radius. It's a very small value. So think of the answer. Micron, nanometer, Fermi, angstrom. Yes, this is an easy question. You know it's angstrom 10 to the power minus 10 meters. That's the answer. And moving into the second question, which of the following is not a unit of energy? Yes, watt into seconds, nanometer energy, joules energy, kg ms minus 1. That's unit of, yes, that's momentum, mass into velocity. Right. Third question, what are meter measures? Yes, first answer, that's easy, electric energy. Fourth question, which of the following are dimensionless? Yes, think of the answer. Take your time. Refractive index, Poisson's ratio, universal gravitational constant, specific gravity. Refractive index, yes, dimension is there. Poisson's ratio, refractive index is, if you don't remember, think of 1 over n equals sine c. So c, it doesn't have dimensions, so n, again, no dimensions. Again, you can think n2 over n1 equals sine I over sine r, no dimension, no dimensions, no dimensions, correct? Poisson's ratio, that's not in our syllabus, but no dimensions. Universal gravitational constant, yes, it has dimensions. Specific gravity, that's relative density, density divided by density of water, that's correct. A, B, and D, all correct. Right, moving into fifth question. Potential is measured in watt, joule per coulomb, Newton seconds. Potential, yes, if you remember the definition of potential, it's, yes, think of it. Yes, work done on unit charge when it is brought from infinity to a certain point at an electric field. So it's, yes, work per unit charge. So it's C is our answer. Question number 6. Which of the following is an example of a scalar quantity? Velocity, yes, it's a vector. Force, it's a vector. Angular momentum, it's a vector. So the last one, electrostatic potential. Electrostatic potential is work done, yes, per unit charge. So it's a scale. So answer is B. Let's get into the 7th question now. If the error in the measurement of radius of a sphere is 0.1%, you can see the question here, then the error in the measurement of the volume will be, right? So errors actually we add. To get the volume, actually we need to multiply radius, r cube, but we here we add the error value. So 0.1 plus 0.1 plus 0.1, so its answer 0.3%. 8th question, electron volt is a unit of, yes, work done. So it's electron volt is, it's a work. W equals, it comes with W equals VQ equation. W work, electric work equals V into Q. So charge of an electron into volt, electron volt, that's energy, right? 9th, read the question. A man is So second, yes, a man is at rest in the middle of a horizontal plane of perfectly smooth ice. He can move himself to the shore by making use of Newton's first, second, third, and all the laws. Think of it. Think whether he can move or not. So how he would make to the other end? Yes, it's the answer. It has to be, yeah, third law. Every action has equal and opposite reaction. So third law is our answer. C is our answer. Right. Moving into 10th question. A man is on frictionless horizontal plane. It is possible for him to get off the plane by spitting or sneezing, rolling his body on the surface, running, none of the above. So think of the answer. By rolling his body, he won't be able to do anything because it's frictionless. Running, not possible. So spitting and sneezing, yes. Conservation of momentum, applying conservation of momentum, m1 v1 equals m2 v2 principle, yes. Conservation of momentum, spitting and sneezing, A is the answer. Right. 11th question. A monkey sits on the pan of a spring scale kept on an elevator. The reading of the spring scale will be maximum when the elevator is stationary. If it's, yes, think of the answer. First, read it. Is stationary, cable breaks. I think it falls freely towards the earth, accelerate downwards, accelerate upwards. Yes. If it's stationary, it's just mg. We know that. And cable breaks and it falls freely, again no reaction. Actual reaction will be 0 by then. Acceleration downwards, g minus a, so m into g minus a. Acceleration upwards, m g plus a. You should know these by doing questions. Actually, if you remember it, that's perfect, correct. So D is our answer. Moving into 11th question. In an elastic collision, momentum is conserved but energy is not. Energy is conserved but momentum is not. Both momentum and energy is conserved. Neither momentum nor energy is conserved. So think of the answer. For an elastic collision, we know that what is constant? Energy is conserved and momentum is also conserved. So both momentum and energy are conserved. C is our answer. Moving into 13th question. When two bodies stick together after the collision is said to be, right? So if you have done questions, you know this. So when two bodies move together after collision, that means the energy will be lesser. So we can directly tell it by looking at the collision. So it's completely inelastic. The answer is C, right? Moving into question 14. A rocket works on the principle of conservation, mass, linear momentum, energy, angular momentum. I hope you know the answer. Linear momentum, right? Moving into 50th question. Which of the following is not completely inelastic collision? Right, this is a good question. Completely inelastic. We have seen the question before. Completely inelastic means just by looking at it, we can tell it's inelastic. Right, striking of two glass balls. Bullet strikes a bag of sand. They stick together. An electron captured by a proton, again stick together. A man jumping onto a moving car, they move together. So answer, it has to be yes, you know it. It's answer A, right? Moving into question number 16. Now we are in question number 16. A particle revolves round a circular path with a constant speed. The acceleration of the particle is its constant speed along the circumference of the circle. Yes, it's constant, so no acceleration. Along the tangent, again, no constant speed, so no acceleration. Along the radius, yes, it's in a circular path, so it's towards the center along the radius. So answer is C, right? Moving into Question number 17. A car moving on a horizontal road may be thrown out of the road in taking a turn. By gravitational force? No. Due to lack of proper centripetal force? Yes, because of the centripetal force only the vehicle will move in the bend. So it's due to the lack of proper centripetal force, but let's read the other two as well. Due to the rolling frictional force between the tire, no. And by the reaction of no. So answer is the B. Answer is B, due to the lack of proper centripetal force. Okay. Question number 17. If a gymnast standing on a rotating stool with his arms outstretched suddenly lowers his arms, you must have done this experiment in school. His angular velocity decreases, his moment of inertia decreases, his angular velocity increases, his moment of inertia increases. So when he lowers his arms, his moment of inertia will decrease. So here we need to apply I1 omega 1. I1 omega 1 equals I2 omega 2. So if I decreases, omega increases, conservation of angular momentum. So his moment of inertia decreases, his angular velocity increases. If you could get the answer, that's great. You remember the theory. Question number 19. I think I have missed one question. It's okay. Question number 20. Right. When the external torque on a system is 0, there will be conservation of external torque is 0, right? Think of the answer. Tau equals 0. Again, conservation of momentum. I1 omega 1 equals I2 omega 2. Conservation of linear momentum, angular momentum. It's conservation of angular momentum. Moving into question number 21 now. Right. The pressure of the bottom of a liquid tank does not depend on, yes, think of the equation. H rho G equals P, acceleration due to gravity, density of the liquid, height of the liquid, area of the liquid surface. You can see from here, it's G is the answer we are looking for. Question number 22. A piece of ice has a stone in it and floats in a vessel containing water. When ice melts, the level of water in the vessel would, yes. If you have done this type of question, the answer will directly come into your head. If not, think of it. There's a piece of ice there's a stone inside piece of ice. So remain unchanged, fall, rise, may rise, yes, the water will fall. Yes, water actually gives an upthrust for stone, and when it melts, the piece of ice melts, the stone will yes, inside it will be inside water, and the upthrust is not enough now, so water will fall down, right? So answer is B. If you couldn't get the answer for this, there are plenty of questions in your syllabus, so find the questions and try it. Question number 23. The operating principle of hydraulic press is, kind of easy question. You know this, it's Pascal's principle. Question number 24. A floating body always displays its floating, remember it, mass, volume, weight, none of these. Simple answer, weight of the liquid, because it's floating, upthrust, U equals mg, so its upthrust has to give weight, so weight of the liquid. Moving into question number 25. Now we are at 25. A boat loaded with rocks floats in a swimming pool, and man in the boat throws rocks overboard in water. the water level will, yes, just same as the other question we read about the melting ice. Again, yes, upthrust is not enough now for the, so the water will fall. Right, moving into the other. Question number 26. This is a bit of a good question. A body is just floating in a liquid. If the body is slightly pressed down and released, it will sink to the bottom, start oscillating, come back to the same position immediately, and come back to the same position slowly. Right. So here the answer, actually think of it. So body is just floating in a liquid, completely immersed. Mg equals a downward force is equal to the upward force. And slightly pressed down, that means an unbalanced force is applied. The velocity is given, right? So downwards there's no upwards. When it is going down, upwards there's no other force other than upthrust. So what happens is there's no other force to balance the downward force that is given to. So it will move downwards until it hits the bottom. So answer, yes, sink to the bottom. 20. A body is just floating in a liquid, so in that question, yes, sink to the bottom. That's the answer. Bernoulli's theorem is applicable to flow of liquids, viscosity, surface tension, static fluid friction. Yes, it's an easy question. So answer is the first one, flow of liquid. Right. Question number 28. Bernoulli's principle does not explain, yes, curved path of a spinning ball, okay, lift of a jet, working of a paint sprayer, automatic blowing of the roof of a house during blizzard in hilly areas. Right. Think of the answer. Curved path of the spinning ball, yes, Bernoulli's lift of a jet. A jet is not considered as a plane, only aerodynamic shape lift is Bernoulli. So answer is B. Question number 29. Bernoulli's theorem is based on the conservation of mass, momentum, energy, all of the above. Right. Think of it. It's conservation of energy. I hope you know that. Right. That's the answer. Question number 30. Our last question. If a stream of air blows under one of the pans of a physical balance, so see, this is the pan, physical balance, in equilibrium, the pan will. So what happens? Think of it. Stream of air is blown under one of the pans, blown under one of it, right? So velocity is higher, here the velocity is smaller, so here pressure is smaller, here the pressure is higher, so force will be applied downwards. So physical balance and equilibrium, then the pan will, stream of air is blown under, yes, one of the pans and physical. So go up or down depending, yes, it goes, yes, higher pressure to lower pressure, it goes down. Answer is B. Right. So all of these questions are from mechanics. So if you could do these questions, that's great. And if you couldn't, at least if you got more than 10 questions wrong, you have to consider your theory first. So go through with theories again. We'll meet from the other lesson, waves and oscillation, soon.